Use the shortcut and concept distillation column to simulate the following: compounds, ethanol and water, property package, NRTL, inlet stream, mass flow, 100 kilomole per hour, mole fraction of ethanol, 0.5, mole fraction of water, 0.5, pressure, 1 atm, other column properties, reflux ratio 1.5 times the minimum reflux ratio. Light key, ethanol, heavy key, water. And the mole fraction for distillate is 0.99, while for the bottoms it's 0.01. To determine the actual number of stages and minimum reflux ratio using the shortcut column. What are the reboiler and condenser duties of the column when using CAMS? So using a shortcut distillation column, we will determine the actual number of stages and minimum reflux ratio. So first we will add our compound, which is ethanol, and water. Then for our property package, we will use an RTL. For the then for our units, we will just consider our desired units. So for the temperature, pressure is ATM, molar flow is kilomole per hour, finish. Second, we use the shortcut distillation column in our flow sheet, then we will rename the stream the materials and energy stream. Change it into inlet. This is what then the next thing that we will do is to input the parameters needed for the inlet stream. So here the pressure is 1 atm. The molar flow should be 100. Checking the amount of compound, it's 0.5 and 0.5 for ethanol and water, which is correct. Then we click this shortcut distillation column. So for our light key compound is ethanol, our high key compound is water. So with this, for the calculation parameters, the distillate since we select ethanol as our light key and water as our heavy key. With this, the concentration of water is higher. It, the concentration of ethanol is higher in distillate than product. The distillate concentration of ethanol is 0.99. Hence, the likely mole fraction in bottoms it will be 0.01. Similarly, the high key mole fraction in the bottoms is 0.99. So the high key mole fraction in the distillate is 0.01. So these are correct. So we click solve flow shape. And here we obtain a minimum reflux ratio of 1.93202. But as you can see, we don't have a value for the actual number of stages in optimal feed stage. So in this problem, it is said that the reflux ratio is 1.5 times the minimum reflux ratio. So in here, 1.5 times the obtained minimum reflux ratio of 1.93202. And now we have a minimum reflux, we have a reflux ratio of 2.89803. So from here, the actual number of stages the actual number of stages obtained is 23.0956, while the minimum reflux ratio is 1.93202. So for this problem, there is a second question in which what are the reboiler and condenser duties of a column when using CAMSEP? So we will use CAMSEP. For CAMSEP, we will need to add an inlet stream. Then in this inlet stream, the pressure is 1 atm, the molar flow is 100 kilomole per hour. Then second, we need to add two material stream and two energy stream. And we will rename these streams. So for CAMSAT, we need to click the escape open tab, then grab the escape open unit operation in the flow sheet in order to add it. Then a window will appear in which we will choose CAMSAT column/flash. Then we click this distillation column, another window will appear. So we need to change the unit name. So for the number of stages, I want it to be 23, so I'll change it into 23. Then for the thermal properties, we change it into ChemSep and OK. Click OK. So another window appear. So for the cape open section, we expose energy ports. Click that. And for the properties, for the K value, which is decima, in which the equation of state is automatically I choose ideal gas law. For the activity coefficient, which is NRDL, then vapor pressure is calculated using Antoine, and for the enthalpy, which is ideal. Then we go into the column specs section. So for the top specification, it's reflux ratio. Then we will change this value according to the value that we obtained, which is 2.89803. And for the bottom specification, we select mole fraction of a component, which is 0.01. Okay, so there's no component as you can see here. So I'll just save this first. Okay. Save this first and connect the material and energy stream into our ChemSep distillation in the two distillate two bottoms two where so we open again the open cape open object editor. Then when we go to the column spec, this is correct. We need to put ethanol in here. After that, save. And click solve flow sheet. So using ChemSep, distillation column, we found out that the condenser duty is 2,086.47 kilowatts, while the reboiler duty is negative 2,268.53 kilowatts. Comparing the answer using shortcut distillation column, we can say that I have to change the values are different at the same time, quite the same. For the condenser duty, the answer is quite close with each other, while in the reboiler duty, the answer that the camset distillation column obtained is it's much higher. It's quite much different since it has a negative value. I think the factors that affect these answers is because of how we manipulate the parameters and other options in this cape open in this cape open object editor.